Hello all. In this video, we're going to talk about image arithmetic. So this is ways in which we can manipulate images just by doing basic arithmetic operations with them. And with that, we can do quite a number of different interesting image processes to make our images look better, different, interesting, whatever it might be. So you see here in my notes, I have a couple of common uses that we might have. So brightening or darkening an image is one of the most common. So we can change the overall brightness of the image. We can change the balance of brightness between the different channels of the image. So we can make simple changes to specific channels. We can combine two images together or pieces of images, and we can do image blending. So here in my notes document, I have some examples, but what I'm going to do is actually just take a look at some things that we can do similar to this first example for the first, and then eventually we'll work our way toward blending images. It's a little more complicated than that. All right, so I have a sample here, and I'm going to flip back and forth from looking zoomed in at just PyCharm itself, where we're looking at the code, and looking at my whole desktop so I can show you the resulting images. So it'll be a little bit of flipping back and forth as we go forward. Let's talk through what this is showing first, and then we'll actually run it and see what the results look like. So I'm importing CV2. I'm also then reading in this Canyonlands picture. I chose this one because it's a very beautiful sunset picture from the Canyonlands National Park, and this was when my family was actually there many years ago. And it's one where we could perhaps want to brighten it up a bit and see if we can make it look like it was taken at a different time of day. So I have here two approaches to brightening the image. In the first, I am just using the plus operator. And it just so happens that because orig_image is a NumPy array, even though I'm not importing the NumPy module, it knows how to do this this NumPy array arithmetic. It's part of the definition of the object, how to handle the plus operator. So because this is an image, it will do numpy's plus, and what we're doing is adding 50 to every number in the image. So every value in the blue channel, every value in the green channel, every value in the red channel. They'll all get an addition of 50. The second one is doing the same thing, but it's using OpenCV's arithmetic, because here we have this situation. NumPy implements all of these arithmetic operators for us, but OpenCV also has arithmetic operations because this is just something we want to do to images. And so they have some differences, and part of what I want to show you with this example is the differences that can happen between the two different operators. So you can decide which one you want to use. So cv2.add is just an addition operator. It works on two images if the images are the same size and dimensions. It also will work on an image and a plain number, which is what I have here. So this should do exactly the same thing as the previous line. It should add 50 to every single pixel, every single color value in the image. The blue channel, the red channel, the green channel, all of those. All right, that's all I'm doing here except for actually displaying the two. So I'm going to run this program, and then once it's run, oops, sorry, I'm clicking in the wrong place. Once it's run, I'm going to shift so that we can look at my whole desktop and we can see the results. All right, so I'm going to kind of lay these out on either side, and I'll put the original picture right in the middle so that we can really compare them up close. So here you see the original picture. It was taken at sunset. There's a lot of shadow. It's hard to see anything in the foreground. There were some heavy clouds in the background, so we want to brighten it. What you see down below is NumPy's addition operator applied to this. And if you can see it close enough, which I'm not sure you can, if you can see it close enough, then you can see more detail. It's definitely brighter. But you notice there are these weird color artifacts up here in the sky and in a few places in the ground where things just are the wrong color. It's just like it's totally messed up the color in the process. You don't see that with the OpenCV version. This is actually a difference between how they handle arithmetic. So what is happening over here? If you know anything about fixed size numbers, you might be able to figure this out. If you think about what parts of the image, especially up here, are having an issue, they are the brightest points in the original. Right up here along the top is where it's almost white in the clouds. And that might give you a hint. But I'll tell you what it is. It's a problem that we have when you have an array of fixed size integers, and it's called overflow. What happened was the actual values for the red, green, and blue, especially these places in this one where they're black, the values for the red, green, and blue are really close to 255. And when I try to add 50 to that, they would go over 255. But the thing is, we can't represent numbers greater than 255 with 8 bits. So what happens is that it overflows and the arithmetic operation throws away anything that goes beyond 8 bits. It only keeps the bottom 8 bits of the result of the arithmetic. And so it overflows, and the way that we perceive that is it's like it rolls around. It's like an odometer that has gone all the way to its largest number, and then it rolls over and goes back to 0. That's what happens here. If you are at 255 and you add 1, you get 0. If you're at 255 and you add 10, it's going to go to like 9 or something like that. So it rolls over the values to the bottom end of their range. Why do we get these weird colors like this bright teal that's down here in the middle of the picture? Because not every channel rolled over. Not every channel had overflow. Only some channels did and some didn't. Where it looks black, that's where all 3 channels overflowed. If you see red, that means that the blue and green channels overflowed and the red value is all that's left. Where you see the teal, it means only the red channel overflowed. The blue and green were low enough that we were able to add 50 to them and they were just fine. But when we take away the red, make it a really small number, then all of a sudden this reddish landscape turns into teal instead. So when you see this kind of a strange artifact happening, you can be pretty sure that something has gone wrong with overflow. Now, the same thing would happen if we were making the picture less bright and we subtracted a number from it. You can have overflow that happens at the bottom where it would go negative and we don't have negative numbers. So again, it flips around to the top of the range in that case, and you'll get these strange color artifacts. So is this something that tells us we should not ever use NumPy arithmetic? No. What it tells us is we need to be careful because this arithmetic has unexpected potential side effects. If we know that we can safely add to an image and it will not have overflow, then we can use NumPy arithmetic. OpenCV's add function actually pays attention to the possibility of overflow. And it doesn't do the arithmetic operator in exactly the same way if overflow might happen. It instead, it notices that overflow is going to happen, and it simply sets that colored value to the maximum. So if it would overflow and go over 255, it sets it to 255. If we're subtracting and it might go under 0, it sets it to 0. That takes extra work. So if you actually timed it out down to the microseconds, you would find out that the NumPy arithmetic is way faster than the OpenCV arithmetic. So it's faster but riskier versus slightly slower but safer. So it's something we have to think about when we're doing arithmetic on images. But also note that it worked to brighten the image. When we used the add function, we got a version of the picture that was brighter. I'm going to go back and we'll take a look at some more simple examples where maybe we won't have overflow. But just in case it might happen again, I thought I would talk about this example first. All right, so I'm going to comment out this example, and we're going to take a look at some simpler examples that are a little bit further down in my file. So I'm going to read in a wild columbine picture. This is a picture of just a little columbine flower with a green background. And what we're going to do is to take a look at some ways that we can modify only certain channels at a time. All right, sorry about that pause. I just realized I don't want to do the examples that I have commented out. I'm just going to make up an example on the fly. So the wild columbine is a picture. It's got a lot of green and it's got only red where the flower actually is. Suppose that I want to reduce the green in this picture. So I am going to tell it to do arithmetic on only that green channel. The green channel is in the middle, blue, green, red, so it's at position 1 in the channel scheme of things. So I'm going to tell it I want to change the image, all rows and all columns but the one channel, and I'm going to change it by subtracting 20. We'll see if that makes a visible difference. If it doesn't, I'll increase the number. But we're doing here basically NumPy arithmetic. I think we're pretty safe. There's a lot of green in this picture. If we get any weird artifacts, then we'll know that we can't do it that way. And then we'll just take a look at the results. So I want to look at the original for comparison and new. Oh wait, I'm changing the original. Huh. Okay. I'm going to show you how you can keep the original and change a copy. So there's a copy method that images have, and so I'm just making a second copy, and then I'm just going to change these references to image 2. Okay, so I'm going to change the copy and keep the original the way it was. Change this to be new, and then I need a CV2 wait key just to end things off. All right, let's see what this does. All right, I'll just put these up here in the corner right next to each other. The one on the left is the original picture, and the one on the right is the one where I have reduced the green. There might be one little speck in here that is an artifact where I've actually had overflow happen. You could call it underflow, but technically the word is overflow even when it goes the other direction. But you can see that the background is darker. The flower stem is darker. Everything is darker because I have reduced the amount of green. It's also shading a little bit more towards blue because that's what happens. All right, so let's go back and look at the code again. So you can see that I can change the brightness. If I added more here, if I subtracted more from the brightness, I would probably see it. So if I tried to remove 50 from this picture and I run it, oh, when I run it again, wait till you see. Ooh, 50 was too big to use NumPy arithmetic on. Where it didn't overflow, you can see that it's much, much darker. 50 is quite a bit when the range is only 0 to 255. But yes, we have a whole section here that was already fairly dark in the original, and we've just caused a terrible overflow here. The green value flipped from low and small up to the top of the range, and now it looks really bright green. It's kind of a fun effect, but it's not what we're looking for. All right, so I could stop there. There's another example that I can do, and so I want to do one more example. I'm going to read in another picture so that I have 2 to work with. Image 1 and image 2. Sample images. I have this mushrooms picture, which is also a nice picture of just some little mushrooms sitting there. I don't know if they're the same size. So this next step, what I want to do is to actually combine these two pictures together. So maybe add them together and see what the result is. So the problem with that is that they may or may not be the same size, and you can only apply arithmetic to images that are the same size. So we might have to do some slicing in order to get an image at the right size to be able to do what we want to do. Okay, so I'm going to comment out this last part just because we're not ready for it yet, and just run this. Yeah, see, they're one pixel off. Well, not quite. Well, one of them is slightly larger than the other. The wild columbine picture is 480 pixels tall, and the other picture is slightly smaller. So I'm going to just crop the larger one, which is image 1, so that it's the same size as the other one. So crop M1. All right, so I'm just going to use slicing to carve off the bottom part of the wild columbine picture. And then I'm going to see if they actually look like they're the same size. All right, now they look like they're the same size. So crop M1 and image 2, these I can actually combine. So we're going to make image 3 is just going to be crop M1 plus image 2. And I could do this with cv2.add. Let's do that. If I do it with cv2.add, then we won't have any problems with overflow. Oh. I kind of need these back now. Live coding is good because it shows you that I don't do everything perfectly the first time either. All right, so we have our originals. I actually displayed the original. You can see that the original, oh, sorry, I have to switch over. You can see that the original mushroom picture was slightly smaller. And then what I've done here is I've just added the two pictures together. So you can see the columbine flower, you can see the mushrooms. They are both there, but notice how bright it gets here where there's actually like stuff going on, things going on in both images. And even like the stem of the flower is much brighter green than it was in the original. That's because we're adding brightness values together. If I tried to do this with NumPy, it would have a huge problem with overflow. But here, OpenCV is preventing that from happening, but it does just let things get super bright. So adding two images together does blend them. We think about what we're doing. We're taking the blue at any particular pixel location. We're taking two different blue values from the two different pictures and we're adding them. And we're doing the same with the green and the same with the red. Why should it happen to look like an actual blended image? I don't know. It's just kind of a cool thing in how our color representations work. But yes, they are blending. We have one image where we can see both of them, but they're too bright because we just added them together. What we'd really like to do to blend the images is to average. We'd like to take the two blue values and not just add them together, but average them together and do the same with the green and the same with the red. And that will give us an actual blend where the colors stay the same brightness that we were used to before. Okay. I am going to show you how to do that. It's really easy. Let's go back and zoom in on the Python code. Here I did add. I added the two images together. There is another function in the arithmetic toolkit that OpenCV gives us called add weighted. And what you do is you give it the two images that you want, but after each one you specify a weight value. If you want the resulting image to have the same relative brightness as the starting images, you make sure that these two weights add up to 1, and then that will happen. So we're basically saying take 50% of crop image 1 and take 50% of image 2 and add those together. So it's a way of doing the averaging, but it allows us also to do weighted averages, and I'll show you that in a second. So let's just run this, and I'll go switch us over. So now you can see that they are blended, and each of the individual items look a little bit less bright than they do in the original because we're blending a mushroom from this location with just a dark green background, so we get a little kind of ghostly mushroom here. But we have a nice, beautiful, ghostly columbine flower as well. So we can do this add weighted where they're weighted evenly. That does just average the values together. What we could also do is emphasize one over the other. So maybe I want 75% to come from the original wild columbine, and I'll make 25% come from the mushrooms picture. Here's our blend. And now what you have is a main picture that's showing up fairly clearly, the columbine, with ghostly little mushroom shapes and grass behind it. All right, so this shows you some of the pitfalls of doing arithmetic on images, especially using a simple tool like NumPy versus the slightly more elaborate tools that you get with OpenCV. It also shows you some of the things you can do, changing the balance between red, green, and blue, shifting the colors slightly, making something brighter or darker, or taking two images and blending them together. All of these things are great tools, and we're going to expand on that in the future by also looking at some additional tools as well. I will see you very soon.